In this video, we will do another example of a set proof, where we prove that one set is equal to some other set. So in part A, I want to use a Venn diagram to find another way to write this set. So we got the intersection of A and B union with the intersection of A and C. So to get this started, let's draw circles for A, B, and C. And they are going to be within some universal set, which I'll call U. So let's shade this in. A intersected with B is the region common to both A and B. A intersected with C is the region common to both A and C. And then the fact that we're unioning them means that we shade in all the values that are in either portion, either this first intersection or this second portion. All of those we need to shade in. So let me just shade that all in one color. So the first intersection, anything in the first intersection or anything in the second intersection, all of that is part of the union. So part A says there's another way to write this shaded region besides the way that we have here. And I'm going to give a hint for this, but then I want to give you time to try it and see if you can figure it out. It's to write A first and then have A intersected with something. And here I want to give you a chance to pause it and try to figure out what that is. So pause it for about 2 minutes to try this. 4, 3, 2, 1. Pause it for about 2 minutes to try that. All right, so hopefully you paused it to try it. So it turns out that it's A intersected with the union of B and C. If I take the union of B and C, we'd be shading in everything that's in either one of those two circles. And then the fact that we are intersecting that with A will just leave us with this orange region. We've actually seen this identity before. It's the distributive law, which we've seen in a previous video. But here we're just giving a visual kind of explanation for why we'd expect this to be true. So in part B, I actually want to prove that the first way that we had written it equals the second way, A intersected with B union C, like this. So recall from our previous videos, if I'm trying to show that two sets are equal, I need to show that the first set is a subset of the second and the other way around, that the second set is a subset of the first. So I want to have us focus on the first direction first, showing this first set is a subset of the second. And I actually want to give you an opportunity to try this on your own first. As always, these pauses in these videos are the most important times because it gives you an opportunity to see, well, how well do you understand this stuff and can tackle it on your own. So if you find yourself stuck at times, that is very normal, but you really want to push yourself to think about this and see if you can move past those times when you do get stuck. So pause it for 5 minutes to try this. 4, 3, 2, 1, pause it and try it. All right, so hopefully you do that. Let's bring it back together. Let's talk about it. So to show that this first set is a subset of the second one, I'm going to first do some scratch work. And in doing this subset proof, what I get to start off by assuming is I'm going to let X be an arbitrary element of the first set. A intersected with B union A intersected with C. And what I want to show is that X is an element of the other side. A intersected with parentheses, B union C parentheses. Okay, so let's try to break these down a little bit. If this is what I get to assume is true here, because I have a big old union, that means, well, X is either in A intersected with B or X is in A intersected with C. And now that's going to give me two cases. The fact that X is in this intersection means, well, X is in both of them. So this will mean X is in A and that X is in B. That's one possibility. In the second case, what it tells us is that X would be in A and X is in C. So we have these two cases here. So are these cases going to tell us that this is true about X? Sometimes when we are doing the scratch work, we may have to work with what it is that we want to show and think about, well, what would it take to show this? Like X being in this intersection, what that means, what it would take to show that is that X is in A and X is in B union C. That's what I would need to demonstrate. Well, in the first case, the fact that X is in A takes care of the first part. The fact that X is in B, well, if X is in B, it's definitely in the union of B and C, because the union of B and C is typically bigger than just B is. Because to be in the union, it means I'm in B or I'm in C. Okay, so nice. So this first case will lead me to both parts of this. But it's the same thing for the second case. X being in A takes care of the first part. X being in C automatically means it's part of the union. Because if I draw B and I draw C, well, if I'm in C, I'm automatically part of the union, because the union is anything in either one of those circles. Okay, so nice. So at this point, we have a connection between what it is that I know and what it is that I want to show. And once we've reached that connection, that means we have all the details that we need for the proof. So let's start the proof. All right, so I start off by writing down what we can assume is true. Let X be an element of the first set. A intersected with B union A intersected with C. Then we write down the definition of what that means. Well, if I'm in the union, this means either X is in the first part, A intersected with a B, or X is in the second part, X is in A intersected with C. Well, okay, this gives me two cases to consider. So the first case is that X could be if X is in A intersected with a B. I'll have to think about that. And case 2 is if X is an element of A intersected with C. And remember that what I'm trying to do is follow my scratch work and get the connection between each of these cases and what I want to show. So if X is an element of A intersect B, remember the next thing that we said was this. This means then that X is an element of A and X is an element of B. That's what it means to be in the intersection. Okay, so already I have one part of what I want to show, X being in A. The other part, the fact that X is in B union C, well, that follows from the fact that I know X is in B. So since X is in B, B union C means X is in B or in C. But if X is in B, it's definitely in B or in C. So because of this, X is automatically in the union. X is automatically in the union of B or C. Okay, so now we have the two key parts. X is in A, as well as X is in B union C. That's enough to say it's in the intersection of the two. So this implies that X is an element of A intersected with, parentheses, B union C, because it's in both of them. Okay, let me give myself a little more room. Case 2 is really similar. Because X is in this intersection, then that means X is in the first thing, A, and X is in the second thing, which is C. And now I'm just following the track that we did here to get to what it is that I want to show. Well, I already know X is in A. The X being in the union follows since X is in C, it's automatically going to be in the union. X is definitely then going to be in the union of B or C, because that means X is in B or in C, which is definitely true if X is in C. Okay, so this now implies, because we have X is in A and X is in this union, this implies that X is an element of A intersected with the union. So collectively, we know X is in this intersection. So thus, because that's what happened in both cases, thus, X is an element of that intersection. And that's precisely what I wanted to show, which means at this point, we've established that it's a subset. So the left-hand side, union, and then, whoops, sorry, this is A intersected C. That left-hand side is indeed a subset of A intersected with parentheses B union C. Okay, so we've shown this direction of the subset proof. The other direction I'm going to leave for you all as a practice problem. So this is actually going to be something that's on the homework, because I think it is really important for you to get opportunity to really practice and try this.